Well, hi everyone. Just want to take on this practice test here. Um, this part we will be doing without the calculator. Um, Number one, A, rewrite e to the negative 0.5 is approximately 0.607 in logarithmic form. So this is e, so I'm going to use natural log, that's the log base e, of 0.607 is approximately, this is a rounded value, negative 0.5. Here we got a log. I'm going to go log base 3 of 243 equals 5. Now, number 2 is doing it same thing, but in a different, going to this exponential form. Natural log is log base e of 9.210 is approximately 10,000. B, 4, that's the base, exponent's 5, 4 to the 5th power is 1,024. Number 3, we need to evaluate these. Now, I think if you do the math, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is log base 2 of 2 to the 5th power. That cancels. We are left with just the 5. This is log base e of e to the negative 6th power. That's equal to negative 6. E to the natural log of 9. Now, it works this way too. E to the log base e of 9 is equal to 9. Those things just cancel out. This is log base 3 of 3 to the 3rd power. 3 times 3 times 3 is 27. So that is equal to 3. Log base pi of pi doesn't have to be a whole number. Log base pi of pi is 1. Log base 4 of 1 is 0. And it doesn't matter what that is. If we're taking the log of 1, we're going to get 0, regardless of the base, as long as it's a legal base. Now, you can get your calculator out for this part. And this is the rational functions part of the test. It says, use the function 3x squared minus 5x minus 2 over x squared minus 4 to provide the information asked here. First thing is, are there any holes in the graph? And I won't know until I factor this. Okay, so we got to work on our factoring techniques. Now, I'm going to factor it this way, but I am going to show also how to factor. Okay, so I need negative, so I think a negative 2 here, positive 1 here. That gives me the negative 2 multiplying 3x times x. And this is negative 6x plus 1x is x minus 2. Now, x squared minus 4, that's x plus 2 times x minus 2. All right, now, the x minus 2's will cancel out. So the simplified function is 3x plus 1 over x plus 2. I'll just keep that over to the side there. So the holes. Okay, notice it canceled out that x minus 2. That 0 for x minus 2 will be the x coordinate of the hole. And I'm going to plug the 2 and the x here and here. So I have 3 times 2 plus 1 over 2 plus 2, putting that in for x. So I'm going to make this 2, and that is 7/4. That is a hole in the graph. The zeros of x, everything I'm going to do from now on is going to come from this simplified function. The zeros of f of x are what makes the numerator 0. 3x plus 1 equals 0. 3x equals negative 1. X would be negative 1/3. That is the one and only 0. Vertical asymptotes. That comes from the denominator, and x is equal to negative 2. The whole comes from that factor before it was simplified. The vertical asymptote comes from the one that was remaining. Equation of the horizontal asymptote, if you'll notice, n equals m. So y is equal to 3 over 1. 3 over 1, or y equals 3. That's the equation of the horizontal asymptote. I'm going to draw the asymptotes, the 0, the holes. I might even put in the, I didn't mention the y-intercept. The y-intercept would be 1/2. That's not something that I had parsed out there. The y-intercept's 1/2. Make the x's 0 and you'll get 1/2 there. But let me just start by drawing the asymptotes first. Let's see. X equals negative 2 is a vertical asymptote. Okay, and when you're showing this, I want you to make sure you put everything in, all this information we have, and even some more. Y equals 3. We're going to draw that horizontal asymptote. A 0 at negative 1/3, so we are hitting the x-axis right around there. Let's see what else. Oh, a hole at 2 7/4. That's 1 3/4. Here's 1, here's 2. So we have a hole right here. And y-intercept of 1/2. Okay, I really have a good idea what's happening right here. We have to get a critical value to see what happens over here. But I really think we're following this asymptote coming up, curving to the hole, around it. So I think that's one of the curves. The other curve, I want to find what f of negative 4 is. And take 3 times negative 4 plus 1 over negative 4 plus 2. And that's negative 11 on the top, negative 2 on the bottom, 5.5. So at negative 4, we are at 1, 2, 3, 4, 5.5. Alright, so I think we're up here like this, and we come down here like this. Okay, so there is the first one. The second one is right here. Okay, so on this one, are there any holes? I'm going to try to factor this. Is there anything, I always look for 2 times negative 3 is negative 6. Multiplies to negative 6 and adds to 7. And I don't think that's going to work, because negative 6 times positive 1 is not going to add up to negative 7. As long as both of those signs are different, that's not going to happen. Because if it's multiplying negative, one's got to be negative, one's got to be positive. So this won't factor. So the answer is no. Zeros. Alright, so on this one, it doesn't factor, but I'm going to see if 2x squared minus 7x minus 3 equals 0. Oh, that's the wrong place. No, that's the right place, the numerator. Alright, so I'm going to use quadratic formula. x equals negative b plus or minus square root of b squared minus 4ac, all of that over 2a. Alright, so that's 7 plus or minus square root of, this is 49, 8, 3, 24. 49 plus 24 is 73 over 4. Alright, I'm going to approximate this now. We've got to put it on the grid, so let's get a good idea where to do it. I'm more interested in its practical place on the grid. So 7, let me put that in parentheses. Not like that. So 7 plus square root of 73 delete that, go past here, make it parentheses, divided by 4. So that's about 3.89. Take the plus out and put a minus in. Minus. That button's almost disappearing. I can't find it half the time. And negative 0.39. I'm just rounding for those two answers. The equation of the vertical asymptotes, it does have a vertical asymptote at x equals 3 from the denominator. Zeros come from the numerator. Vertical asymptotes come from the denominator. It has a slant asymptote this time. All right, and your favorite algorithm. You know what? X minus 3. We could use long division. I'm going to use synthetic division, though, because x minus 3 is a good divisor for synthetic division. Put 3 in the box. Let's go 2, negative 7, negative 3. Draw the line. Put the 2 down here. That's 6. That's negative 1. Negative 3. That's negative 6. So I'm getting 2x minus 1 minus 6 over x minus 3. Alright, this part's not important. The equation, okay, I don't want to say it's not important. As x gets really big, either in the positive or negative direction, it has very little factor in the thing. Y equals 2x minus 1 is our asymptote. Our slant asymptote. Okay, so I'm going to draw this slant asymptote down here. Negative 1 up 2 over 1. Okay. Now, okay. Actually, that's a, I'm not going to, it's a dotted line anyway. I can keep dotted lines between these points, right? Alright, so there's my slant asymptote. We do have a vertical asymptote at x equals 3. Okay, now we got to find out where the curves are. Part of what will help is knowing that 3.89 is a 0 and negative point, like right around here, 39 is a 0. I have a feeling that we're talking about right here, and right here for our graphs. Let's see. So what I'd like to see maybe is what, I'm going to see what f of 5 is real quick, just to get another point in there. And that's 2 times 5 squared minus 7 times 5 minus 3 over 5 minus 3. Okay, this is 50 minus 35 is 15. 15 minus 3 is 8. 15 minus 3 is not 8. Okay, I forgot what it is. 15 is 12. 12 divided by 2 is 6. It's like right there. So I think what's happening is we're going like this and then getting close to the line as it keeps going that direction. That curve is doing that. All right. Now, I'm just curious. Oh, what's the y-intercept? Let me put that in. 0, that's negative 3 over negative 3, which is 1. So it hits the y-axis at 1. So I think it's close here. Comes out here a little bit and then gets back to the line like that. So I think that's what we're looking at there, guys. All right, there you go. Short and sweet.